My name's Orin. I am now, as of the end of October, a Microsoftie. But up until then, I was a regional director like Magnus, except for I was obviously a regional director for Australia. But I actually knew Magnus and had met Magnus, so I'd met someone who basically runs your user group a long time before I'd actually come here. And as I said, it's my first time in Sweden. The funny thing is, and I was saying this to Michael, my son has been obsessed with Malmo for many years, and I don't know why this is, but he's insanely jealous that I am here tonight. So he's asleep obviously at the moment, but he made me take photos as I was going across the bridge because he watches the bridge because it's on Netflix in Danish, it's in Australia. It's got subtitles, so but he's obsessed. And I was told that there's a museum about the bridge, and he went, "Really? Oh God, why am I not there?" And I was like, "Because you're at school, and you're meant to be studying." Anyway, so what I'm going to talk about today is Azure Operations Security. So my role at Microsoft is what's called a Principal Cloud Operations Advocate. You may have heard of the developer advocates, and the developer advocates are there to basically entice people to develop and publish on Azure. But one of the things that Microsoft realized was that there's a whole lot of people that were interested in infrastructure type topics that weren't getting served by Microsoft evangelists talking to them. So as I come from an operations background, some of you may know I've written a ton of books on Windows Server, and then I've done a ton of Pluralsight courses on Azure Operations. I was one of the people that they came and recruited for this role because I understand Azure from the operations perspective, and I think about it very much from the operations perspective. And it's always been my feeling that the developer mindset and the operations mindset, even though we've got something called DevOps, they're different. They're substantially different. That a developer is very much about creating and getting something into production and worried about just getting it there. Someone who's in operations is much more about checklists and ticking boxes because they're the one that's going to get called when it doesn't work. An operations person is very much interested in stability first. A developer is more interested in getting something out there and then getting to stability later on. So I think it's a very different mindset. And I think that the audiences do need to be approached in a very different manner. And that's something that Microsoft is coming around to at the moment. So, the idea of this talk is I'm just going to go through, and this is condensed from a full day workshop, into the things that you can do to make your Azure subscription more secure. And most of these exist on what we'd call the management plane. These are when you're thinking about developing or deploying into Azure, you're thinking about the workload itself. So you might have an application or a VM that you're deploying and you're worried about what's going on inside that VM or what's going on inside that application. But there's a whole lot of things outside that application that need to be tightened up, but you've got to know what you've got to do. And the reality is, as Azure is very new and the cloud is very new, we're not used to thinking about all of these things. If I said to you, I want to deploy a virtual machine or a server on a perimeter network in my environment, you'd sort of mentally have a checklist of all of the things that you needed to do to make that workload secure. If you're deploying in the cloud, you won't have a similar checklist simply because you haven't grown up with it and it's a completely different environment. So that's a bit what this talk's about. And the first question I want to ask is, are you absolutely certain that you know what you're responsible for when it comes to security and what other people are responsible for? What Microsoft is responsible for, or your other cloud providers? Because what I have found is that the vast majority of people don't. I've gone into companies and consulted with companies and I've said, okay, I've just looked at one of your VMs and you haven't patched this in 3 years. Why haven't you patched your VM? We thought Microsoft did it. We thought that the cloud was that we deploy and everything gets looked after for us. And that's not the case. So there's a thing called the shared responsibility model. Now the shared responsibility model is a differentiation of who is responsible for what. And Microsoft has made this very clear, but as human beings, sometimes we don't necessarily see what we don't want to read. And some people who have jumped in cloud first, head first into the cloud, have said, oh, it's great, everything's going to be looked after for us. All we need to do is deploy the code, and that's it. We don't need to think about it. But the reality is you do. So this is some quotes from a Gartner talk, where security is the biggest reason that most organizations are reluctant to go into the cloud. Startups are very, very cloud focused. Traditional enterprises are going to be much slower in adopting the cloud, simply because if you are explaining the cloud to someone who's not an IT person, it becomes a very complicated discussion very fast as to what the benefits are. And one of their big questions is, so we're taking something that we've got locked in a room, that we've got secured, and we're going and putting it in someone else's data center, and everybody can access it over the internet. And if you're not an IT person, or a person with an IT background, this starts to become quite frightening. So, the key statement here is only a small percentage of security incidents impacting enterprises with a fault of the cloud platform. Now, that's not us blame shifting. That is us saying, if you actually understood what you're responsible for and what we're responsible for, most of the time the problems are going to occur in the part of the stack that you're responsible for. The misconception is that we're responsible for the entire stack. So if we're looking at it, what Microsoft's committed to is saying, we will look after the security of the data center. So if you're trying to get into an Azure data center, it's really, really, really difficult. In fact, as an employee, we have to apply to go to visit a data center, and I went and visited one of the research data centers, and even then we had to get all of our documentation in place and be checked. It was very, very, very complicated. The operations of the data center, making sure the power works, making sure everything works, and the infrastructure, the systems that it's built on. Microsoft's entirely responsible for that in Azure. However, there's a joint responsibility when it comes to things like apps, virtual machines, and data. And what happens is that Microsoft will give you the tools with which to secure these things. But we have a saying in Australia, and I think it's a global saying, it's not just ours. You can lead a horse to water, but you cannot make the horse drink. And what that comes down to is that we can give you all the tools in the world, and so you need to use these controls to secure your workloads, but we can't make you go and do it. So, in terms of baselines and best practices, I'm actually doing a doctoral thesis on the security compliance accreditations that are applied to cloud workloads. So I do know a little bit about this aside from my role at Microsoft. But from your perspective, there are a couple of organizations where you can go and get free sets of checklists to assess how well you've actually applied security controls in your organization. One of them's through the Center of Internet Security. There's also a group called the Cloud Security Alliance that publishes the Cloud Control Matrix. And then Microsoft ourselves, we publish the Azure Security Best Practices and Patterns documents, which is a list of documents on docs.microsoft.com simply saying this is where you want to go. And I've created a short URL, acker.ms/azsec-best practice, and that will give you a link into all of those best practices documents. Now, Azure Security Center, which I'll talk about in a minute, actually allows you to assess your deployment against 3 of the most common security accreditations. So you've got ISO 27001. Now, ISO 27000 series is around computing security. 27017 is actually the one specifically related to cloud computing. So it's an addendum to 27001. Now, in this particular screenshot, I've got very few workloads deployed. But the more workloads you've got deployed, the less likely you are to be compliant by default with all of these standards. So the Azure Center for Internet Security benchmark, and then you've got PCI DSS, which is the payment card industry benchmark. And again, what have you got going on? So some of the things that it'll look at, if you've deployed a VM workload, it'll look at whether or not you've got the hard disk encrypted. If you've got the hard disk encrypted, that will allow you to pass one of the standards in one of these. If you haven't, it will be flagged as something that you're not compliant with. So Azure Security Center is a product that Microsoft has that allows you to look at and assess the security posture that you've got in your subscription. So it'll look at your organizational security policy and compliance status. It'll continuously assess your security state and tell you where you're not up to scratch. And it'll allow you to optimize your security by configuring appropriate recommended security controls. An example of this, another one, having an anti-malware solution on your virtual machines. You can push button deploy anti-malware solution into your VMs from Azure Security Center. And that's going to be one of those things that's within the compliance regulations. Are you running your virtual machines with anti-malware solutions? And this isn't just Windows operating systems, this is also Linux-based operating systems as well. So with policy and compliance, I showed you that a little before, and it's showing which controls I've got passed there. There's another dashboard that will come in and say, okay, looking at your computing, your networking, your IoT, your data and storage, and your identity and access controls, which ones have you turned on? Which ones have you not turned on? With Azure Security Center, what it'll do is it'll make recommendations, and it'll also generate a thing called a security score. Now, the security score is individual to your organization and based on what resources you've got deployed. So it's not a matter of your organization saying, I've got a score of 1,000, and the next organization saying, I've got a score of 2,000, and them necessarily being better or worse. They could have 2,000 out of 5,000, and you might have 1,000 out of 1,100. So what it'll do is it'll work out a total based on what resources you've got deployed, and then it'll give you a score based on that. But the good thing about that score is that it'll allow you to see how you've improved. My recommendation to anybody who does Azure Security Consulting at a very basic level or is just getting started is to go in and look at someone's subscription, turn on Azure Security Center, and then take a screenshot of the score. And then simply what the Azure Security Center will do, it'll give you a checklist of things that you can go through and remediate that will improve that score. So you take that first screenshot, and that's your before screenshot. And then you go and remediate those issues, and then you're able to show whoever you're consulting for or whoever you're working for how you've substantially increased their security posture on a nice graphic that will suit management because it's all colourful and it's got a lot of things that management understands because they're a bit like Montessori children. Threat protection. Azure Security Center looks at attacks that have occurred against your subscription. So again, you can't see any here. There's only one low severity attack where someone has apparently tried to log in using one of the accounts. If your account is under attack, you're able to go through these and see what kind of attack is occurring. And I'll talk about this a little more in a sec when I get to Azure Sentinel. There's adaptive application controls. Adaptive application controls. So one of the things that we know about workloads that run in the cloud is that the majority of workloads that run in the cloud are still virtual machines. So what most people are doing is that they're adopting the cloud, but the way that they're adopting the cloud involves them actually running virtual machines rather than things like platform as a service. Simply because a lot of organizations understand how virtual machine works, they don't necessarily have the funds or the ability at the moment to rewrite their applications so that their applications are going against directly the Azure Fabric. So with adaptive application controls, this is something in Azure Security Center, and what it does is you turn it on and it'll actually go and look at what applications or what executables or what binaries are running on that virtual machine environment, and it'll profile your virtual machines so that it gets an idea of the usual application execution patterns on your virtual machines. If that changes substantively, adaptive application controls will actually flag that for you, and you can actually configure it to block the execution of unusual applications. So the idea is it will profile, these are the applications that run on this VM, and then suddenly if something changes, because maybe your virtual machine's been compromised, it will block the execution of those applications. File integrity monitoring. basically looks at the config files, the registry files of a running VM, and understands what those look like normally, and then will flag for you if those files are changed. So if you suddenly come in, you'll be alerted there's been massive changes in the registry, or there's been massive changes in the config files. Again, those are indications that that virtual machine might have been breached, or it might have been you doing it, but it's going to warn you about it. So security playbooks. One of the things that we're moving towards is an automated set of responses to security incidents in the cloud. So the idea of a security playbook is that if you see a recognized pattern of activity that you flag as suspicious, you can have an automated response occur to that activity. So let's say that one of your VMs starts running unusual software, but it's happening in the middle of the night. You might have a playbook that just goes and shuts down that virtual machine until such time that you can come and look at it. Because is it better to have a virtual machine that suddenly started sending spam around the world, or is it better to shut down that application until someone can come and look at that virtual machine? You might have a playbook that automatically spins up a brand new fresh virtual machine and shuts down and deletes the current one. That could be one thing that you do. So you can automate your response using logic apps, and you create a logic apps workflow using a Security Center event as the trigger. So the other thing that Azure Security Center can do, and Azure Sentinel, which was just recently released, talks about this, is Azure Sentinel is a SIEM, a Security Incident and Event Management System. But one of the things that Azure Security Center does, and Sentinel does as part of this, and one of the things that the cloud's very good at, is taking an insane amount of data, processing it, and looking for and recognizing patterns within that data. And when it comes to security, that's really, really useful, because what happens is that attacks have certain patterns of behavior that become evident within the data. So the idea is, with having machine learning examining all of your event telemetry and all of your monitoring telemetry from all of your systems, be they virtual machines, be they applications, be they databases, whatever you're running in the cloud, you can hook it in so that all of that telemetry is going in one place, and then you can have your security systems looking over that and then flagging based on anomaly detection whether or not there's something that requires your attention. So this is very different from the way that we did security in the past. In the past, we would have a box that might sit on-prem that was programmed to look for certain types of signatures. It might run regexes or something like that against the log data, and then it would flag what it knew how to recognize. What we're getting now is, of course, it's got a whole list of things that it already knows how to recognize. But with machine learning, it's getting smarter. So what it's looking for now is anomalies that require further investigation. And with something like Azure Sentinel, when an anomaly is detected and Microsoft's not sure about it, it'll kick it over to a bunch of security researchers and say, well, do you think this is something that's worth investigating or not? And if it is, they'll then flag it in future as an attack. But where this is very difficult for attackers is, in the past, you could use a unique attack multiple times because the security systems didn't know how to detect that attack. With something like Azure Sentinel, the intelligence on recognizing that attack is automatically shared across all nodes. So it's not that Microsoft's sharing your data with everybody, but they're sharing the recognition of the pattern of the attack that might have occurred against one customer, so that all customers are aware of that. So that's one of the benefits of something like Azure Sentinel. So this is what Azure Sentinel looks like. It's analyzing attacks or suspicious events against your infrastructure on a constant basis. So we can see here that there's something going on in South America and Africa, and of course Australia's not doing anything because they're all asleep or lazy. In terms of data connectors, you can plug everything into, well, not everything, but a lot of things into Azure. From your on-prem hardware security devices, you can plug other things in. The other thing that you can do is you can bring data out of Azure Sentinel into your own security and incident and event management system. But you can see here it'll plug straight into Active Directory, identity protection, advanced threat protection, security events, Windows Firewall, AWS systems, Checkpoint, Cisco, ASA, the whole thing. The idea is, with the cloud, It used to be when you were looking at event logs and event telemetry, you had to manage the size of your, again, you probably have heard the expression, finding a needle in a haystack. Now you can build insanely large haystacks, and it doesn't matter how small the needles are, because with machine learning, you can find those needles. Okay, so here's another question when you're thinking about securing your environment. And securing your environment isn't just securing it against attackers. It's securing it against stupid stuff that happens that shouldn't. Okay, the vast majority of security events are accidental. It's like someone leaving the door open or someone leaving the door unlocked. So how do you stop people accidentally deleting resources? I've been in situations where someone's come in and someone's accidentally deleted a bunch of VMs, or someone's deleted a bunch of VMs thinking that they're okay, and then found out that actually they were part of a mission critical workload. We had an event like that just before one of the Ignite tour stops where someone had gone through and deleted a whole lot of demo virtual machines. Now, I pre-record all of my demos, so I was fine, but there were other people on my team who were not having a good morning that morning when we found that out. So, resource locks, very simple technique in Azure. All you do is you go and put a lock on something. The lock means that unless the lock's taken off, you can't perform certain actions against it. So the first one is cannot delete. It means they can modify the properties of the resource, but they can't delete it. To give an example, you could resize a virtual machine, but you couldn't delete the virtual machine. Or read-only means that they can't actually modify or delete the resource. Now, with a virtual machine, understand that this is at the management plane. So I'm saying you can't delete the virtual machine, you can't modify it. What you can do is you can remote desktop or SSH into the virtual machine and delete everything inside it, but we're talking about at the Azure level. How do you can control who interacts with specific resources? Another big one we all see, especially with startups, is you walk into a startup and there on the whiteboard is the login account for the global administrator subscription, and right below it's the password. Why? Because we're a startup. We don't have all of that hierarchy stuff going on. We're just going to have one account and everybody's going to be able to do that. No, that's really, really poor security practice. Or everybody in the organization has global administrator privileges on the subscription, including the administrative assistant. Because the administrative assistant might be the person who goes into Azure Active Directory and goes and creates new accounts. So there's a better way to do it. Role-based access control. Role-based access control is a security idea that you have a level of permissions, and then rather than applying them globally, you apply them over a set of objects. So that instead of giving someone the ability to go and create virtual machines anywhere, you actually limit their ability to go and create virtual machines to a specific resource group. And then you only give that person the ability to create a virtual machine. Or it might be that you say, right, we've got the new person, I'm going to give them the ability to restart a virtual machine, but they can't do anything else. They can't stop it, they can restart it, but they can't delete it. So what you are doing is you're working out the minimum necessary privileges that someone needs and only giving them that. It's sort of like you don't go and give someone, when they go and work in your office, the master key to everybody's office. You work out what office spaces they need access to and you give them those keys. So you can grant access for resource groups and subscriptions. So let me give you a quick demo of how role-based access control works. So here I am, and I'm logged on as Jupiter. Now Jupiter can't see any virtual machines whatsoever. So if he does a refresh, no virtual machines there. So what we want to do is we want to give Jupiter the ability to actually manage these virtual machines. And we see that there is one virtual machine called My VM in the subscription. So we go into My VM and we see I'm logged on as Orin. Click on My VM, and what I can do is I can go to Access Control. I can go across to Role Assignments. Now what I'm going to do is I'm going to add a role assignment. I select the role I want to assign. So in this case, what I'm going to do is I'm going to select Virtual Machine Contributor. That means that the person can perform actions on a virtual machine. I then select the user I want to assign that role to, and I click Save. Now, because I've done it on that particular virtual machine, once that role assignment's gone through and Jupyter comes back and refreshes their access, which we'll see when we flip back here, Jupyter, and because refreshing access sometimes actually requires you to log out, Jupyter will log out and then log back in. Jupyter will have contributor level control over that specific virtual machine. Now, all I have done in that demonstration is assign Jupyter permissions on that one VM. So if there were other VMs in that subscription, Jupyter would not even be able to see them in the Azure portal. So the idea is if you've got someone working on a project and they need control over a virtual machine, you assign them permissions only to that virtual machine. You don't let them be able to go and control any other virtual machines that exist in the subscription. So you can see here that Jupyter can go and restart that virtual machine. We'll do questions after we've, or ask me when we're eating. So policy is the next thing that we want to talk about. So policy allows you to, so role-based access control allows you to control what someone does. Policy sort of allows you to control how they do it. So for example, with a policy, you could configure when someone's deploying a virtual machine, what the password requirements for that virtual machine are. What your Azure allowed locations for deploying that virtual machine are. For example, you might be saying, okay, we're running a business here in Sweden. We don't really want anybody trying to deploy virtual machines into an American data center. We've got all of these compliance regulations that we're under. We are only allowing deployments to occur in these specific data centers. The way that you would do that would be through policy. You can enforce the use of resource tags. A resource tag is just a bit of metadata that you apply to a resource. Now, one of the things that you will notice if you go and look at your own subscriptions is no one ever uses these damn things. So if you wanted to see all of the resources that were associated with a particular project, it can be very difficult to tease that out. If you enforce at deployment a resource tag where someone's got to type in what project it's enabled for, and they've only got a limited set of choices that they can choose, you can make sure that every resource in all of your subscriptions is appropriately identified for later. So, and an initiative is a collection of policies that are applied and tracked at the same time. For example, you might have an initiative that is, these are the VM SKU sizes, this is the policy, the resource tags that need to be assigned, and this is the location where these VMs can be associated. So you collect those policies into an initiative. There's a repository already on GitHub of initiatives and policies that people have already made. So you can simply sign on to GitHub under Azure. So if you go to github.com Azure, there is tons and tons and tons of Azure related templates and things that are available there. But there's a lot of policies as organizations have gone, oh, well, this is a useful policy to create. We'll just go and push it up into GitHub and then everybody can go and use it. So let me show you how that works through two demos. So the first thing I'm going to do is I'm actually going to go and create an initiative and I'm going to create the policies inside those. So here I've got two subscriptions, prod and test. So here I'm going to go into the policy blade. I'm going to look at my definitions. So here I've got initiatives and there's a bunch of initiatives. So what I'm going to do is create a new initiative definition. So I specify where I want to locate that. So I specify the subscription it's going to go into and I select that. I go and give it a name. And what this is going to do is it's called cost control. And what we're going to do is we're going to limit the virtual machine versions that can be deployed. So the SKUs, how big the virtual machines are. And we're also going to limit what kind of storage is going to be used. Instead of allowing them to go premium hot SSDs, we're going to say, no, you've got to use the slower, older, but much cheaper versions of the SSDs. So what I then need to do is add definitions. So I've said SKU. So we've got storage account SKUs as the first definition. So if I add that definition in, it comes across here, and that gets added to my initiative. So what I'm going to do here is I'm going to specify the management group. Management group's a collection of subscriptions. I specify the subscription. I then go in and say, right, these are the storage types that are allowed. Standard locally redundant storage and standard zone redundant storage. That's it. No ultra SSD locally redundant storage. The next one, I go to virtual machine SKUs. So I click on that. I go add. Now, here, I click on the ellipsis. I specify my management group. I select the subscription that this is going to apply to. I click select. So again, can now click over here and specify which SKUs are going to be allowed. So here, what I'm going to do is I'm going to only allow a standard D1 SKU and a standard D2. So what I'm stopping is people deploying those Godzilla virtual machines that are going to cost like $5,000 a month. So I've got my two definitions that I've added to my initiative. I go and click save. It'll save that initiative. Once that initiative is saved, we can see it down the bottom here. What I need to do is I need to go and assign that initiative. So I've created it. Then I go and say, right, within my particular management group, I want to add my cost control initiative. So I specify the cost control initiative, which is the one you just saw me create. I click select. So it needs to have a managed identity that applies it, and I click assign. So that will take a certain amount of time to apply. It doesn't go through instantly. It'll take about 30 minutes before that actually goes and applies to the subscription. So once it's actually applied to the subscription, and we can see there that the compliance status is not started. So half an hour passes, we wait for some time to pass. That'll get us into compliance. So let me show you what happens when that compliance occurs. So here we are, and what we're going to do is we're going to try and deploy a virtual machine. So we give the virtual machine a name. Now I didn't do anything about naming, but you can enforce naming schemes using policies. You can select which images can be used. Now here, I can go and select whatever size I want, because the initiative, the policy doesn't get applied until I go to validate that deployment. So you see here, I've got the ones that cost you, $5,000 a month, which is obviously not one of the D1s or the D2. So then I go in and provide my information about my administrator account. And again, you can go and complete policies that all limit this. It's when I click review and create that it goes off to try and validate whether or not that deployment can occur. And when it runs that validation, it comes back and says your validation has failed. You cannot perform that deployment. Why? Because this policy applies. So that's another way that you can go through and secure your subscription. So you can stop people in your organization or people outside your organization firing up one of those really big VMs that no one's aware of until the bill comes in full. And believe me, there's been a few people that have gone and done that because it's like, oh, I need 64 gig of RAM and 32 cores. So the next one. Identity as a control plane. How do you make sure that someone who's got privileged rights is actually using those responsibly? There's a thing called just-in-time administration, and the idea of just-in-time administration is instead of someone being an administrator all the time, they're only an administrator when they request administrative privileges. So think of it like sudo on Linux or user account control on Windows, but sudo is probably a much more easier way of thinking about it. With sudo, you get root level access. Well, think about that with role-based access control. Instead of having a particular role that can do everything when you elevate, you might want to change someone's password. Your account can't normally change someone's password. You can request the ability, someone can grant that ability, and for the next half an hour, you can go and change passwords. That's the idea behind privileged identity management. So let me show you a demo of how that works. So here I am in the console, and I'm signed on as Don Funk, who is an actual person at Microsoft who has the world's most awesome name. So and Don's in a lot of my books just because of that. So what Don wants to do is Don wants to go and reset Sam's password. And he does that and it says, well, you can't go and reset Sam's password because you simply do not have the appropriate permissions. So what we've done is that we've set it up so that Don can actually request the ability to reset that password. So he sees what roles he's able to request, and we've configured the password administrator role so that Don can actually go and request that role. So when you're setting up one of these roles, you can set it up so that a whole lot of conditions apply to the activation of that role. You might have it that someone needs to approve it. So someone else has to sign on and approve that role. You might have it that Don needs to perform multi-factor authentication, but only when he's requesting that role. Why? Because you're worried that if someone gets Don's credentials, it might not be Don. So if Don's actually got to press a button on his phone to say, yeah, it is me, right, I'll let you have that role. You might have it that Don's got to go and put something in the log saying this is the ticket in the ticketing system that I am actually fulfilling when I'm doing this role. But as Don's account is normally, it's just a standard account. It's only when Don requests a role that it becomes a privileged account. And then that privilege only lasts for a certain amount of time. So that if Don's account gets compromised, you've got another layer of security before Don's account can do something that it shouldn't be used to do. So Don clicks activate. The activation duration is for an hour. He provides a reason that's going to be logged in the audit log. I need to reset Sam Abolros's password. Now, in this case, he doesn't need any approvals, and then he's got the password administrator role. So if he goes into Azure Active Directory, clicks on Sam's account, and then clicks reset password, he's now got the ability to actually reset that individual's password. So that's the idea of role-based access control, and then privileged identity management can be married to that. So how do you control traffic to resources on Azure networks? So this is another important one. As I said, most workloads are going to be running VMs, or they're going to be running as web apps. And when you go and deploy a web app, or when you go and deploy a virtual machine, you connect it to a virtual network. And that's one of the things people just go, oh, okay, I'm deploying this, I'm not going to think about it anymore. But Azure will go and give you a private IP address and a public IP address. And there's a whole lot of tools that you can use, just as if you were deploying on a perimeter network, to actually lock down and protect that workload. And I'm going to talk about some of them here. So your network security best practices. Limit your traffic inbound and outbound to that which is necessary. So if you were deploying on your perimeter network, you wouldn't give it a straight public IP address and not put a firewall or something in front of it. Make a multi-layered approach to security. That is, don't just use one solution, use multiple solutions. Okay? As I like to say, it's like Shrek says to Donkey, onions have layers and security is the same thing. Put perimeter networks between your on-prem network and your Azure network. So if you've got VPNs, go and put a perimeter network in there to filter traffic that's coming from on-prem into Azure. And then do the same thing. Use a perimeter network model for every resource that you deploy in Azure, so that there is something mediating the traffic that's coming in, rather than you just spinning up a VM, opening up port 80 or whatever, or 443, and allowing traffic to come in, or spinning up a web app and doing exactly the same thing. Just putting a web app up there and worrying about the security later. You can use Azure Firewall or a network virtual appliance to mediate that traffic passing across your perimeter networks. Control that traffic. So you can use a service called Azure Front Door with Web Application Firewall to mediate and filter traffic from the internet across Azure regions. You might have heard of Azure Front Door. It was only announced recently. It sort of takes what Azure Traffic Manager did and then beefs it up so that it does all of that stuff like SSL offloading and so on. Sort of almost like, but not exactly like, because this is being recorded, something like Cloudflare. Putting Cloudflare in front of your application. This is something very similar to that, except for it allows you to load balance your stuff across regions. And then within a region, you can use Application Gateway with Web Application Firewall as well. I'll talk about that in a minute. You can use Azure Firewall as well, and network virtual appliances, and I'll talk about what those are in a sec. So one of the things that you can do, and one of the things that will give you an understanding of how your resources are exposed, if you go into Azure Security Center, you can actually see which resources you've got exposed to the internet and how those resources are exposed to the internet. So here I am in Azure Security Center. I go down to networking, I click on networking, and we've got the ability to have a network map and also a network topology. So if we bring up the network map, we can see I've got two resources. I've got two VMs that are actually exposed to the internet, my VM2, my VM1. It'll say what networks they're connected to. And then when I drill into each one of these resources, I can then see where it's located, what its public IP address is, some recommendations about hardening these resources. I can even come here and click on allowed traffic, and that'll allow me to pick up the network security group rules and the firewall rules that are actually protecting that particular resource. So here we can see my VM network security group, and we see that we've got RDP traffic, port 3389, open to everything in the world. So at the moment, that's not a particularly great rule, because what's going to happen, everybody's going to be trying to brute force RDP on that particular workload. So there's another feature in Azure Security Center called adaptive network hardening. The idea of adaptive network hardening is you go and point it at a virtual machine, and it will look at the normal traffic that goes in and out of that virtual machine. And it'll use machine learning to say this is a typical traffic profile, this is an atypical traffic profile, and it'll give you a recommendation on how to go and configure the network security group to protect that particular resource. So what's a network security group? Network security group is the most basic form of packet filter that you can go and create within Azure. You can configure it to apply at the VNet, network and subnet level. No, at the subnet and not the VNet level. You can also use service tag. What a service tag is you saying, I want to block traffic to internet, or I want to allow traffic to Azure SQL, or I want to allow traffic to a particular thing such as Key Vault. You can't create your own service tags, but there's a list of them, and that just means that if you've got Azure resources, you can make it very easy to go and create those rules. So let me show you a quick demo of creating a security group. So here I am in the console. I go to network security groups. I've already got that one that was protecting my VM. So that's actually applying at the network adapter level on that particular VM. The other thing to understand about network security groups is that you can have one network security group apply to multiple resources. So you set up one set of rules and then just go and apply them as you need throughout your organization. So here I'm going to create one. I select a resource group to go and store it in. I click create. It goes off and creates that. So once that network security group is created and deployed, I can click refresh, and I've got my network security group. So that one's the one that already existed. And I can see the inbound security rules, and we know that RDP is open to the world on 3389. So that's the one that's already applying, and we can see the properties of that. Any source port through to 3389 on TCP. So what we're going to do now is we're going to look at where that's applying, and it's applying on my VM's network adapter, and it's not applying to any subnets. We come back to network security groups and we go to the one we've just created, and there's no rules there other than the default rules. So what I'm going to do is I'm going to create a rule for RDP as well on that one. Now, when you're creating rules, one of the things that people slip up on is that they are not sure whether or not to apply the rule at the destination port range or at the source port range. A good rule of thumb, destination port range is already pre-populated for you. So that's the one you go and edit. So here, I'm just going to type in 3389. I'm happy to leave it as any protocol, even though it should only be TCP. I give the rule a name, RDP, I click add. It goes and creates that rule. Now, what I'm going to do is associate that rule with a specific subnet on a specific virtual network. That will mean that all traffic coming into that subnet will have that rule applied to it. If the rule allows the traffic gets passed. If it doesn't, it drops it. Now, network security groups are very, very basic. It's source IP address or range, destination IP address or range, port and protocol. We can get more sophisticated with that. And when we get more sophisticated with that, we're using something like Azure Firewall. So that's just gone and saved that and then applied that rule. So you might have heard, as I said, about Azure Front Door and Application Gateway having Web Application Firewall. What a Web Application Firewall does is it examines incoming traffic to web workloads. And what it does is that the OWASP, who's a security organization, has a list of its top 10 vulnerabilities. And they have a rule set that allows them to detect those vulnerabilities based on the traffic that's coming in on port 80 or port 443. So what Web Application Azure Front Door and App Gateway can do is they can do SSL termination, and then they can examine traffic as it's coming in. So it can automatically go and block things like SQL injection attacks and cross-site scripting attacks before they actually hit your web app themselves. They will be dropped at the Web Application Firewall because there'll be an analysis of that traffic at layer 7. So Azure Front Door has that functionality, and then Azure App Gateway also has that functionality as well. You can also deploy one of our partners' network virtual appliances. All a network virtual appliance is it's basically a virtualized version of one of those hardware boxes that you've got on your perimeter network that has a lot of intelligence built into it on how you go and control traffic coming in and out of your network. So you can go and route traffic through one of these and then manage it using your vendor's built-in tools. However, and at the moment, these things are probably much stronger and much harder because they've got a lot more rule set. These companies have made their living off selling this intelligence and this ability to respond to and manage traffic. However, we do have a solution in Azure Firewall, which I'll talk about later. And you can use Azure Firewall in conjunction with a network virtual appliance, in conjunction with all of those other services. Because remember, it's like an onion. You do layers of security. You do not do one solution does everything. Now, with service endpoints, one of the things that you will have heard about is people leaving their storage account keys in GitHub repositories for their Azure storage accounts or their S3 buckets, and then people coming and using those and dropping malware on those buckets, going and dropping a whole lot of stuff that they want to distribute to the world because suddenly it's free storage. So one of the things that you want to do is that you want to have the ability to lock down a service endpoint. Now, a service endpoint can be storage, or it can be something like Azure SQL, or it can be anything. And what you can do in Azure, and you couldn't do it initially with Azure, but you can do it now, is that you can say that this particular resource can only be accessed from this subnet. So what I'm going to do in the demo is show you how you can set up Azure Storage so that Azure Storage can only be accessed from a particular host on a particular virtual network's subnet, but can't be accessed from any other subnet. So it's not a matter of spinning up a storage account and then having that accessible to the world. You can basically go and put a storage account firewall there and say you are only accessible from this particular location. So let me show you limiting storage account network access. So what I'm doing here is I'm adding a new virtual network. So I'm giving that an address space. So when you create a virtual network, you've got to give an address space. So 192.168.0.0/16. I'm going to specify a location to put it. And when you create a new virtual network, you've got a default subnet. So you start off with one, and I'm calling it public, and I'm saying 192.168.10.0/24. So I've got a public subnet. And I click create. But what I do not do is I do not enable service endpoints. So now that I've got that particular virtual network, the next thing I'm going to do is I'm going to go and create a private subnet on that particular virtual network. Now, the idea behind this one is that I will then deploy, as part of my app, virtual machine workloads onto that private subnet, and they will have direct access to an Azure storage account that nothing else that's on any other network will have access to. So I select service endpoints, and I say here that I want to allow the storage subsystem to have access to that particular network. So once I've gone and done that, The next thing I need to do is I need to go and create my storage account. Now you can apply this retroactively to an existing storage account, but the way I'm showing it here is I'm creating a storage account and then I'm going to apply those rules to the storage account. So I'm creating a storage account, I specify where I want to keep it, I give the storage account a name, I specify the location it's going to be put, the account type, which is going to be storage account, just a general purpose storage account, standard performance, and I'm just going to make it locally redundant storage. So then I go into my advanced settings. And when I go into my advanced settings, I get my option of controlling where stuff can happen. So if I turn on secure transfer, no one can upload data to this storage account unless they've got a port 443 HTTPS connection. The next thing is virtual networks. Now by default, allows access to everything. So what I can do is I can come over here, select a network and say, right, only my new VNet, and then on that VNet, I'm only going to allow access from the private subnet. So I turn off the public subnet. And in doing that, that storage account can now only be accessed by resources that have addresses on that particular subnet. So I click review and create, and that's off and created. So that's how you lock down. Now that works with any of those Azure services, from SQL through to Key Vault through to whatever, including things like Cosmos or whatever you want to do. Okay, so Azure Network Watcher is an excellent tool that no one knows about. What it allows you to do is it's almost like Wireshark for Azure. It allows you to do a whole lot of diagnostic tests against Azure where you can go and track how traffic works between two things. So if you've got two virtual machines in Azure that aren't talking to one another, but you think you've got the networking correct, you could use Azure Virtual Network Watcher to go and deal with that. If you wanted to capture traffic out of a virtual machine, you can again go and use this tool. So let me show you how that works. So here I go and type Network Watcher, and that'll bring up Network Watcher. I select my topology, and when I select topology, what it'll do is it'll give me a topology of everything that's connected to a specific virtual network. So here I've got one virtual network, and you see I've got two virtual machines connected there. The network adapters, the network security groups, everything. It'll show you that as a diagram that you can zoom in and out of and then export it into Visual Studio, not Visual Studio, into Visio 4. So the next thing I want to do is I want to monitor a connection. I want to see if port 3389 RDP traffic can go from one virtual machine to another. And I just want to have that as a regular check going on. I want to know if that gets interrupted. But think about it as the difference between a front end and a back end server. So if I've got, I want to monitor and ensure that that connection exists without logging onto each VM to verify that does. So what I've done is I've created a port monitor there between those two, source and destination, on 3389. Once that's created, I've got the connection test, and that will continue to run, and I just click on it and then it'll say, yep, it's reachable. That connection test is working. So you can go further with your diagnostics. So the next one I'm going to play around with is Network Performance Monitor. You turn on Network Performance Monitor, and basically what it'll do is it'll output data into Azure Monitor that allows you to view the performance across a particular virtual network. So if you're getting degraded virtual network performance, you can actually pull that up in Monitor and actually see whether or not that's occurring, and it's something that you need to look into further. So this is where we've just gone and selected our workspace. So the next one is if we wanted to check whether or not a particular host is contactable. So the way I'm going to do it is I'm going to say if I've got my VM on 10.0.0.4 on port 3389, and I want to make sure that people can RDP into that particular VM given my rules, what I can then do is I can specify a remote test and it'll simulate a connection. So what I'm doing here is I'm giving it an address on the first subnet I ever worked on, which was at Melbourne University in Australia, which is a public subnet, and I'm pretending to make an RDP connection in from Melbourne University to that virtual machine. And it's saying, yep, that access should be allowed. Now, if you remember my NSG rules, it was only 3389 that was open. So if I pretend to make a port 80 connection there, it'll check my rules, and it'll come back and say this access is denied. You cannot perform that access. My next hop rules allows me to check from one particular location to another what the next hop is. So it gives me route, it'll check the routes that I've configured. And it'll say here, well, the next hop there to the Cloudflare DNS is on the internet. Effective security rules allows me to bring up a particular virtual machine and work out all of the security rules that apply to that virtual machine across the network adapter, as well as the virtual network that is connected to. So you can see here, it's bringing up all of those network security group rules and the two network security groups that now apply to that particular virtual machine. You can then perform a packet capture. So if I want to monitor traffic in and out of that particular virtual machine, I can turn on a packet capture. I can give the packet capture a name. I can then specify a storage account into which to record that packet capture. I can specify the minimum number of bytes per packet, or if I put in 0, it's going to capture the entire packet. So maximum bytes per second, I've set 100,000, and I want the packet capture to go over 3 minutes. I can then even apply a filter there. If I only wanted to do port 80 traffic, it would do that. So it'll add that packet capture, and then it'll run that packet capture initially, or I can come back and run that packet capture again at any point in time, and then analyze that traffic using whatever tool I choose, because I can export it from Azure. Now I know that the pizza's there, so I'm just trying to think what I might jump over, because you don't want to have people smelling pizza and trying to look at your talk at the same time. Okay, so what I'll do is I'll drop some of these demos, but Azure Firewall. Azure Firewall is firewall as a service. So here's the difference between Azure Firewall and an appliance. With an appliance, you spin up the appliance and it basically applies a VM size to it. And it exists as a single box. The idea with Azure Firewall is it runs as a service. That means it scales up and it scales down as necessary. Instead of paying a certain fee per month to run a certain VM size, you will pay based on the traffic that's coming in and out. It's got built-in high availability, so if you have one box and it goes down, well, you've got to reboot it and so on and so forth. This one, you don't have to worry. It'll do network and application filtering. So you remember I showed you a network security group? When I showed you the network security group, it was source and destination address, right? Just in IP addresses. Here you can go and put fully qualified domain names in. You can name protocols. You can go and create rules that'll do it that way. And in the demo I would have showed you, you could say, right, I want to allow HTTP and HTTPS traffic to GitHub. And you can create a rule that does that instead of having every IP address that's associated with GitHub and then saying it's all on port 80 and 443. You can also centralize your policies across all of your VNets and have the same policies across all subscriptions. So you can create one policy with all of your rules and then just apply it to all of your firewall instances. It provides you with complete VNet protection. So if you've got multiple VNets, you go and put it in the middle, and then you can mediate all of your traffic through a hub and spoke topology. Now, one of the really, really cool things that this does that other firewalls do not do is Microsoft, through all of its intelligence that it gets through the security graph, which is, if you think about it, there's Hotmail, Xbox Live, Office 365, Azure. Microsoft's got all of these online properties. They've got security researchers. They've got a very good idea. There's only a finite number of IPv4 addresses in the world. They know which IPv4 addresses have poor reputations. They're the ones that might be sitting in Tasmania that are launching anti-malware attacks against people, denial of service attacks against people, doing all of those nasty things, sending spam. So Microsoft has a list of IP addresses that have got poor reputations and ones that have got not poor reputations. You can turn on automatic blocking of traffic to any IP address that's got a poor reputation. Because obviously, if they're going to attack you, if you're getting denial of service, it'll just drop those packets. But if you have been compromised, you certainly don't want your server sitting in a nice European data center suddenly exfiltrating traffic out to somebody's home address in Hobart, Tasmania. So automatic blocking, it's a very cool feature. And of course, because other firewall vendors simply don't have the breadth of intelligence about what goes on the internet that Microsoft has through all of its security properties, they simply won't know what they are. Also, all of the logs from Azure Firewall can get sent straight into Azure Sentinel or into Azure Monitor, where they can all be deeply analyzed by machine learning. So I won't do the demo, but in the demo what I showed is setting up Azure Firewall and a jump box environment so that you had a VM on the public network and that RDP was blocked to VMs on the private network, and so that you had to RDP into the jump box before you could actually RDP into anything on the private network. Just-in-time VM access, the idea behind this one is very similar to just-in-time administration. Rather than having port 3389 open to everybody in the world, what you do is you have it blocked. And if you want to go and RDP into that machine, you go into the Azure console and say, can you please open port 3389? And then for the next whatever period of time, 3 hours, whatever, port 3389 is open. Every request is logged, so you knew who opened that RDP port and then who RDP'd in. You can go and check the machine's local logs. So there was a demo on that. Azure Software Update. The idea behind Azure Software Update is that if you think about what I said before, that the vast majority of workloads running in Azure and in other public clouds are virtual machines, and most people aren't updating these damn virtual machines, and they're running a variety of operating systems. If you have a central process that you can use to keep them up to date, well, this is how it works. The idea is that when you turn on Azure Software Update for a virtual machine, it will check the update compliance of that virtual machine. It'll give you a central console that will then report on the compliance level of those virtual machines. And you can then go and push update runs, not just for Windows-based virtual machines, but you can also push update runs for Linux virtual machines, and then basically keep all of the virtual machines that you manage up to date, and then have a regular update run against them. So think of it almost like WSUS, or System Center Configuration Manager, for Windows and Linux virtual machines using one control panel. So this is just showing the process that goes through to do that. These are all the operating systems that are currently supported for Azure Software Update. So Key Vault is where you keep your secrets and your certificates. This is more a developer thing, but if you wanted to run an encrypted virtual machine, you can keep your BitLocker encryption keys or your DMcrypt encryption keys within a Key Vault so that no one has access to them. The reason that you run encrypted virtual machines is unless you have your VM hard disks encrypted, anybody who's got access to your storage account is able to download the virtual hard disk of that virtual machine, mount it in their own hypervisor, and then get access to the contents of those virtual machines. So we have seen those attacks. So that's why you run an encrypted virtual hard disk on each virtual machine. So anybody who's got access to the storage account can download the virtual machine, but they can't read the contents of the virtual hard disk because it's fully encrypted. Okay, so additional recommendations. Make sure you encrypt your virtual hard disks. Make sure you put antivirus software on them. Make sure if you want to have, if you manage identity through Azure Active Directory, you've got much better control rather than if each virtual machine has its own individual identity. So you can domain join not only Windows boxes, but you can Azure Active Directory domain join Linux boxes as well. So you sign on to a Linux machine using an Azure Active Directory account, which means that you can then enforce things like two-factor authentication and conditional access. With change tracking and inventory, basically you turn it on, you point it at a virtual machine, and what it'll do is it'll give you a log of every change that's occurred on that virtual machine. So any services or daemons that have been started up or turned off, any software that has actually been installed on that virtual machine. I won't do the demo, but I can show you later during Q&A what some of these demos actually look like. Anyway, best practices, aka.ms, azsec-best practice. If you go to that site, you'll get a list of all the current things, and that's being updated on a regular basis. We'll do Q&A after you've had pizza, because I'm sure it's driving you completely nuts being able to smell it. And thank you very much for your attention.